Hi everybody, welcome. In this video I'll be covering about arrays and pointers, and I'll also be touching upon few aspects of why people make a lot of mistakes, and it is very easy in fact to make mistakes while using arrays and pointers. A lot of people seem to understand that arrays and pointers can be used interchangeably, and they feel rightly so, because in a lot of scenarios arrays and pointers can be used interchangeably, whereas it's also important for us to understand that in some particular scenarios it is very important that we understand the differences between the two, so that we can use both of them effectively in our code. To start with, for this video I would like you to recall a few aspects of C programming language. One thing would be the differences between arrays and pointers in terms of the definitions. The fact that arrays are data items of the same type and are contiguously spaced, and also that pointers are variables which would store the addresses of other variables. And the second aspect is that I would like you to recall the concept of an L value and an R value in a C expression. I have covered these two topics in a previous video, and the third thing is the difference between declaration and definition. It's somewhat confusing, both of these terms. But the thing to understand here is that definition is something that appears only once, whereas declaration is something that can be done multiple times at multiple locations. So that's the difference between declaration and definition. And we would also explore a few aspects of pointers and arrays with a few examples. So to start with, I have this file, a header file, wherein I have just defined a character array. So I have assigned it to a string literal A, B, C, D, E, and I have specified hard-coded to be specific the length of the string literal here as 5, and in my other file, in the main program, I have declared the array again as an external variable so that I could use it here, and subsequently I am trying to use these two. So one key thing to note here is that when we define something as an array, we should necessarily declare it as an array. Now, if for example I define it as an array and declare it as a pointer, my C compiler would crib. So it would say error, conflicting types for bread. Bread is the array which we have declared in file1.h. So that is one thing that we should keep in mind. Even the other way, so if you define it as a character pointer, and we would need to compile this again, and if we access it as an array now, that is, we declare it as an array, our compiler would throw the same kind of error. It would say again conflicting types for bread. So it is important to be similar in both the declaration and the definition, and let's keep it as an array for right now. So I'll save it as an array and compile it, and in file2 as well I'll comment the pointer declaration and use it as an array. It was like this before, so we don't need to recompile it. The next thing I want to highlight is that we can use the string function, the string length strlen, from the library string.h. This can be used on both character arrays as well as character pointers with to give the length of the string, and both of them will work. Why does both of them work? Because the only condition for calculating the length of the string is the presence of the null character. So when we define a string as a string literal to an array or to a pointer, in both the cases a null character would be appended at its end, and string length would use that to find out the length of the string. For example, if I run my a.out now, it would say length of the string as 5, and even if I do it as a pointer, comment this over here, and I do it as a pointer now, again still the length of the string is 5. So this thing works irrespective of the style of declaration or definition. And the next thing I would like to bring to note is the concept of modification. Modification of a string literal works only when it is assigned to an array and not to a character pointer. For example, in this case we have defined the character pointer and assigned it a string literal, and we are using it as a character pointer in the next file. So when I try to modify it here, it's interesting to see the output here. So just misplace the comments there. Yeah, this is perfect. And when I try to modify it, it says segmentation fault and code out. Why does this happen? Because the key aspect to note here is that when you define a string literal as a character pointer, by definition in the ANSI C standards, it is an immutable data item. You cannot change any of the parts of the data item when you define it as a character pointer. Only when we define it as an array, it allows us to change. So in this case, if I make it defined as a character array and consequently use it as a character array here, now my code will work without any issues. So I do this, and it basically went through and did my modification and changed each of the characters in my string literal to the character constant a, and subsequently I'm printing it. So that is one aspect. The modification works only when the string literal is assigned to a character array and not to a character pointer. One more thing about definition as a pointer is that only when, suppose we consider the definition char pointer bread equals string literal abcd, this is a very special type of pointer declaration, because only when we declare a character pointer is there a space allocated for the data item. So when we declare it as a character pointer, you're able to basically access any you're able to access the elements here, and you're able to print the data item here. So as before, so when we were declaring both of them as a character pointer, oops, I need to change it here and use it as a character pointer here. So I compile again, do this again. Yes. So basically this allows us to access the individual elements of the string literal, and this works only and only when it is defined and declared as a character pointer. Now, instead of character pointer, if it were another type of pointer, let's say an integer pointer, right? So, for example, let's define an integer pointer like int pointer x equals 5, and let's compile this. So it's just a warning, and when we try to access the value of x using star of x, some of us might expect star of x to print 5 here because we have assigned it in the original file. So when we try to compile this file 2.c, and I will take off the formatting warnings, and then when I try to do ./a.out, I get a code dump. That is because only for a character pointer in its definition is space allocated for the data item that is being pointed to. So when I define char pointer bread equals abcde as a string literal, so we have space allocated for the string literal abcde, and we would assign 5 bytes for abcde. Whereas when we define it as int pointer x equals 5, this definition does not allocate space for the data item being pointed to. So when we try to access that data item, it would lead to a segmentation fault because that data item doesn't exist in memory. So instead, what we need to do is we need to make it point to an item by writing something like x equals ampersand of y, where y is some integer which we have defined again. So this kind of definition doesn't work for an integer pointer, whereas this kind of definition works only for a character pointer. But the key thing to note here is that this kind of definition would not allow you to change the individual elements of the string literal. For example, you cannot make it abcdef or abdbf, something like that. It is basically immutable in this case. Whereas to change, you need to declare it as a character array. So that was about using the definitions and declarations correctly in pointers and arrays. The next thing I would like to cover is basically using pointers to access array elements. So as we all know, the base address of an array is basically denoted by the name of the array. For example, in the character array bread of 5, just writing bread would give us the address rather of the first element of the array. So we can use that idea to print each of the elements of the array bread in this case. So when we write something like bread of I, what the compiler internally does is it does a pointer arithmetic between bread and I. And since pointer arithmetic is commutative, it also works when we write I of bread. This is a very quirky use of the pointer arithmetic, and this is rarely seen in programs used in companies or production quality codes. And another way of accessing this is using a character pointer. So in this case, let's redefine it as an array so that this point is clear. So I declare it as an array again here, and I'm accessing as an array here, accessing as an array here, and here I have a character pointer which I assign to the base address of the array. So my character pointer is here, and I assign the first location of my array to the character pointer by writing char p equals bread. since bread refers to the first location of the array here. And I use char p of I instead of bread of I to print the value of the ith element. Let's see how this works. So as usual, I'll compile the header file again, and it's because of this warning. Let's get rid of this. So file1.h, and let's make sure we are not accessing the integer pointer. Yes, we are not. And I compile this, and here you go. So we get the same value, which is bread of I for character pointer of I, as well as star of character p plus I. This is again equivalent to this. This is basically how the compiler would rewrite char p of I as. It would write it as it would try to dereference the pointer addition of char p and I. So these are the 4 ways of accessing array names in an expression, and we can equivalently use pointers to access array elements. So in an expression, we can always use array names and pointer names interchangeably. Now on to the next topic, which is using array names in function calls. One key thing about C programming is that array names are always passed by reference. So in a function call, as a formal parameter, an array name always refers to the address, irrespective of how it is defined. So for example, let me go up. I have 3 functions here. Maybe make it a bit bigger. Yeah. So irrespective of how we define it here, we see that in the first case we have a char pointer, and in the second case we have a character array, and in the third case we have a character array with the size specified. The key thing to understand here is that since all of these essentially amount to passing the address of the base location of the array, giving the length 500 here has no significance whatsoever, because an array, let's say, of characters would always be terminated by a null character if it is a character array, and we can use that idea to get the length of the character array. Whereas if you have something of an integer array, then even if we specify the size of the array here, the compiler would just pass it as just a pointer to the base address. So this 500 here wouldn't give any further information to the function call here. So to demonstrate this here, I would let me comment this, and let me use the middle one where we defined it as a character array here. So I am calling my function of bread. So bread by bread, and passing the base address of the array here. So I have a compilation of file2 here, and then I am passing the definition containing array of characters as argument, and I am able to see that the length of the array, length of the string passed is 5. Now if I comment the second declaration and use the third declaration, and do a compilation again, it would tell me that the length of the array is 5 and not 500. Why? Because this 500 information does not percolate into the function, because what goes inside the function definition is just the address of the first element of the array. So the string length would then again use the idea that strings are terminated by null characters, to find out what is the length of the array. So that's why we always pass the size of an array as the second argument whenever we pass a non-character array. So if we have an integer array, we always pass the size in addition to passing the array itself, because the function has no way of knowing from just the base address how long the array is. So I'll just show you the char pointer example as well. So in this case, it would again find out that the length of the array is 5. So these three definitions of passing a one-dimensional array is equivalent, and all of these three functions are doing essentially the same thing, and to call either of these three functions, we just need to pass the base address of the array. So those are some of the topics which I wanted to cover in this segment. Hope you enjoyed it, and have a nice day.